All right, everybody. We have our second speaker of the night. Our second speaker is Nick Conant. Nick Conant will be teaching ancient astronomies of the world this semester, so if you are interested, please enroll in his class. Nick Conant is going to be doing our next speech. Please welcome Nick.
Thank you, Hunter. Thanks, everybody. My name's Nick. I'm going to be doing constellations of the past, present, and future. Don't usually get to do presentations about something that's really outside of my purview. See, normally I work at the Fisk Planetarium as a theater and education manager. I've been there for over 10 years, but most of my time I'm actually helping other people with their presentations, so you can actually hear me present for once. For how many of you have been to the Fisk Planetarium? Throw your hands up if you've been there. All right. Yeah, thank you very much. I'm glad to see that you've been there. If you haven't been there, then please come by and take a visit. I'm actually going to be using visuals from the software that we use in the planetarium, Digital Sky 2. So the simulations that you're going to be seeing today are based off of the planetarium software. So I'm going to start with asking you, what do you see here? Last time we did constellation trivia, but I want to see, what do you see in this star field as seen from Earth? Anybody recognize anything? Southern Cross, Draco, Polaris. It's kind of difficult, isn't it? Well, I'm going to label this one with a star right up here, 5-pointed star, because it's going to be hard to keep the star fields apart. We'll come back to this, I promise. This one's labeled to the moon. What do you see in this one, if anything? Orion. I heard 2 Orions. M87. Ooh. Wow. So, okay, not a lot of guesses. You guys are really stumped, it seems. Well, that's good. You don't have to recognize these constellations yet. We're actually going to give you a chance at the end to really appreciate what these are. But to appreciate where constellations came from in the first place, I'm going to go all the way back to Ptolemy. He's the first one to write it down, so to speak, besides some of the ancient, say, Egyptians or Babylonians. Just as far as the Western constellations go, he's writing it down. That's what makes a difference from just not science and real science, is whether or not you write it down. Fast forward a few hundred years, we get to Al-Sufi. One of the Arabic constellation dudes was putting in constellations from Ptolemy's work. He decided to do a view of, say, this one. What's this one, do you think? Orion. Yeah, you guys recognize Orion, but in Arabic style. You've got Betelgeuse and Bellatrix and Orion's belt in the middle. And he thought, well, what about if you were in space? If you were Orion looking down at the Earth? And also if you're on the Earth looking up at Orion. So he drew 2 depictions of each of the constellations. I think that's pretty interesting. He also added in all the Arabic names. So something like a third of all the stars that we reference have Arabic names, and that's where this comes from. Fast forward a little bit. We have a bunch of other people adding in constellations, especially once you get to the Renaissance era. There's a surge in constellation creation. Everybody wants to have their creation in the sky. And the idea of having a telescope now means that, well, you can find more that nobody has really ever seen. But still, we have these folks. Of course, we have Hevelius, we had Bode, we have Nicolas Louis de Lacaille. He went down to the southern hemisphere at the Cape of Good Hope and actually made an observatory to try to get a whole constellation map of the southern hemisphere the Europeans weren't really familiar with. And through his work, he added 14 constellations, but hardly anybody knows his name. Finally, we arrive at sort of the modern era, and around the 1900s, we have something like over 100 constellations in the Western culture, and that's just too many. There was the Polish ones, there was the Greek ones, there was the German ones. There's too many constellations. What are you going to do? Well, when you have a problem like this, you have to have a meeting. And yeah, don't I know it? So you have a conference, that's right. So you get professional astronomers from across the world, which just means at the time America and Europe, you can figure, and you put together an International Astronomy Union. So the International Astronomy Union gets together, and they have this dude, Eugene Delporte, who's a Belgian astronomer. He's supposed to figure it out. So he comes up with a list. He has some help from an American. They put together a list of the constellations I think everybody across the world will recognize. Their world will recognize. I mean, they didn't ask me, but they asked the people back then. And they threw together this list, and as they presented it to different people, everybody said, yeah, those constellations make sense to me. That's what I would recognize. And they narrowed down the list to just 88. Well, in 1922, the IAU officially adopted these 88 constellations covering the sky. Here they are. Quite a mess. If you thought the periodic table was bad, imagine being an astronomer today trying to understand that. Yeah, so even us at Fisk, how many of you are Fisk? Raise your hand. I want to see your class. All right. Yeah, you guys probably don't know all 88 of these. Neither do I. They are really scattered. But let's just say, though, that the new ones they accepted, they only accepted like the Dutch, the French, the Polish, but they left out the German constellations. Anybody want to guess why they left out newly made German constellations? World War I. Yeah. There's this little thing called the Great War, the First World War, and they were still pissed at the Germans, so they left out all the German constellations. So that's how that went. Now, there's been a thing with the IAU. They've been calling these official constellations, as if they're somehow scientific. Now, this is a little bit of my platform to get on. You all at Fisk have heard me rant about this. How can you have an official scientific constellation when if you were to uninvent them, you would never be able to reinvent them the same way? There's no way that this is scientific at all, and yet the IAU calls it the official constellations. In fact, they would have you believe that the sky really should be divvied up like this, and all cultures on Earth see the sky the same way as all of the different boundaries of constellations, all the stick figures belong just like this. And well, I'm trying to get them to get rid of that way of thinking. And so to do that, we're going to get you first to get rid of that way of thinking. I'm going to ask Ray to play this video for us. You can just click on it. This is the Earth. Hope you recognize it. We're looking down at where we are right now. This is actually set for right now, right here. And as we back away from the Earth, we're actually going to see the different constellations are differentiated throughout space. As you see these beautiful pictures in the sky, the stars are actually separated by vast differences. So we're going to have to leave our solar system behind, leave our sun behind, and we'll start to see the different constellations up here. We've got, for example, Orion over here, Orion's belt. Sirius, one of the nearest, brightest stars. And as we fly through interstellar space, you see the stars are really like dissociated in outer space. It's hard to make constellations from this distance from Earth because, well, I mean, it looks like there's a little bit of bias in how we made them. So some like aliens would have visited us from outside the Milky Way and come visit Earth, and they would say, you know, how do you divvy up the sky? And we're like, this way. They'd be like, I think that's a little bit biased. Isn't science supposed to be impartial? Well, this also, you notice, only in this little patch of the Milky Way, something like 1% of the stars around us that we can see. There are hundreds of billions of stars in the Milky Way galaxy, but only a few million that are actually within the realm of our constellations. Maybe tens of millions. There's one other problem. I know you're already thinking about it, you astronomy enthusiasts, which is that stars orbit around the Milky Way over time. So in 250 million years, the sun will have gone all the way around the Milky Way once, and that really is going to swish things up a lot. So over time, the constellations can't stay consistent either. So how are you going to say these constellations are the official scientific constellations that won't change, that they will last forever? A hydrogen proton will always have one proton. But these constellations, we have to make them new all the time. So here's the star field to demonstrate how we're going to transfer through time and go into a place where the IAU has not been yet. So let's start here. Anybody recognize the constellation in here? Okay, you guys all know as Big Dipper, the Big Dipper, Ursa Major. We're actually going to, let's see. Can you play this video, please? I'm going to ask you, how far do you think it would take for us to go through time before we see the stars moving around the Milky Way? Is it 1,000 years, 10,000 years, 100,000 years?
100,000.
Well, we're already going about 1,000 years. Now we're going about 10,000 years into the future. So you see them moving now? Well, here's 100,000 years into the future. Ursa Major is not looking so hot. And there's 1,000,000 years into the future from the present day. The stars around the Milky Way are going to be scattering all across the night sky. It won't look anything like it used to look. So if you want to make a constellation now, you can go to a place where the IAU doesn't have any official constellations. This is your spot to say, you know what, I think I see something that's not a bear. Maybe I see my cat, or the drink I'm having right now. I should put it up in the sky, like right there. All right, let's see. Can I go next? All right, so knowing that stars move, what do you think this constellation was from the very beginning of the talk? Well, we're going from 1,000,000 years in the past all the way up to the present day. And so that picture you saw was actually set from 1,000,000 years in the past, and it is the Big Dipper. It's Ursa Major. And the next one, this one that you guys saw as perhaps Orion, here's a few answers for that one. Let's actually see what it was. If we would go from 1,000,000 years in the past all the way to the present day, we're going through the evolution of the human race. We have star clusters zooming past the Earth. There's the Hyades star cluster. Here's Aldebaran. Here are the Pleiades coming into view, and it's Orion indeed. Good job. Give yourself a pat on the back if you guessed Orion. Yeah, 500 points. Very nice. Making sure I'm staying on time here. All right. Well, if we go a little bit further, here we go. Let's take Orion, before you play this, Ray, let's take Orion into the future, and I want you to see if you can predict what's it going to look like in 1,000,000 years from now. How are these stars going to change, right? We just saw it 1,000,000 years in the past to the present day. What's it going to look like in 1,000,000 years? Hit it, Ray. Here we go. We've got Betelgeuse and Bellatrix. Not moving very much. These stars are quite far away. Here go the different star clusters. A few other bright stars enter and leave our field of view. And if any of you guess this, you get 1,000 points. These stars in Orion are predominantly very far away, so they're not moving very much as seen from the Earth's field of view from our perspective. But over the course of the next 1,000,000 years, this is what the constellation of Orion will look like. It's not very easy to pick out the original constellation of Orion, but if you were still trying to send a message of the constellation to your progeny, to your super great grandchildren, and say, look up at that constellation, they might be a little confused. In fact, if you look at it now, this is something that we like to do in the planetarium. Try to find a constellation for yourself. There's no official constellation here anymore. What would you see here? A scorpion? A paraglider?
A lot of bees.
A lot of bees. Oh yeah, beehives everywhere. They won't know what bees are in 1,000,000 years. Just a little social commentary. Save the bees. Well, this star field has never been seen probably by the IAU, so if you want to make your own constellations in the future, make it now and then patent it. All right. And here's one that I want to share with you. This is a very special star field, and I really encourage you to make a constellation right now for this, because I tried looking it up. I can't find anybody on Earth that's made a constellation out of this star field. A stick? That's a very fancy stick. Lacrosse stick. Oh. Did I hear raccoon? I think I see the Flatiron there. You know, I think we need to make an astronomy on tap constellation. You know, maybe if I give a talk again, I'll find where it is in here. Put an AoT in there. Well, this is indeed our sun as part of a constellation as seen from Proxima Centauri, our nearest star system with a planet around it. The nearest star to our sun has a planet in orbit around it, an exoplanetary system. So this is the view looking back toward our sun from Proxima Centauri. You can see Cassiopeia You can see Perseus, if you guys know those constellations, Capella, the bright star, and Auriga. Our sun would be right about there and be about that bright. Now, if you go any further into the night sky, the sun is actually pretty much doesn't appear at all. If you go to Vega, the sun is so far away, you pretty much can't see it. So only from Proxima Centauri do you really get a sense of what our sun would look like from another world. All right, thank you. Any questions?
We now have 5 minutes for questions. Does anybody have any questions for Nick?
Yes, please.
What is the story about Beetlejuice?
What is the story about Beetlejuice? What do you mean necessarily? Oh, as far as the actual star itself. Betelgeuse is a very interesting star. It's a red star. It's grown very old. It's swollen up to being extremely big. This is what we call a red supergiant. So stars that reach this kind of point in their life and this kind of mass are actually so big that they're going to die by exploding. Betelgeuse is not large enough, we think, to make a black hole when it explodes, but it'll probably form a neutron star. It's a very massive star. It's going to form in its core something that has the mass of the entire sun, but in an area about the size of Boulder. So imagine the entire sun crushed into an area about the size of Boulder. That's what Betelgeuse is going to make when it dies. Now, Betelgeuse is also questionable because it is a weird amount of distance away. We don't know how far away Betelgeuse is, despite being one of the largest stars in our night sky. In fact, it could be somewhere between 300 light years away and 600 light years away. The best estimates are put it somewhere in between those. And one more fun fact is one of like a dozen stars we can actually resolve the angular size of. Most stars appear as points, don't you know? If we look at them with our best telescopes, stars only appear as point sources. You can't tell the difference between the left and the right of the light coming to you. But Betelgeuse is so massive that our telescopes can actually tell the difference between the left and the right, and we can see the width of the star. So this is a very unique star. It goes through brightening and dimming, as we saw a few years ago. It's so big it's going to explode in the future, and it'll make a glorious view in the night sky. Hope that gives you a lot to think about.
Do you have any more questions for Nick?
What's my favorite constellation? You know, that's a good question. I say the Pleiades. You know, the Pleiades has been seen by every culture on Earth. Every culture has made some story about it, as far as we know. Every culture we can think of has made some story about the Pleiades, and the fact that we can't really tell if there's 6 or 7 stars in the Pleiades from the ground, that different cultures will have stories for 6, and different cultures will have stories for 7. If you're in the highest, driest places, right in Chile, you can see something like 14 with the naked eye. I've been able to make out 11 Pleiades with my naked eye from the darkest location I've been at. But I have to say that the Pleiades really takes the cake. They're so glorious, they're so beautiful, and there's so much more to see there. Now, you guys who say they're not a constellation, sure, they're not an IAU official constellation, but I don't know what official means in that context. So every culture on Earth knows it as a constellation. So if you disagree, you disagree with like the planet. Other questions? Yeah.
So in these videos that we've been watching, like how far along is like the Milky Way, like Andromeda, like collision course? Like how we can watch it?
That's a good question. The question is, how far along is the Milky Way Andromeda collision? The collision between these two major galaxies in the local group. Well, if we were to play this video again, please, Ray, this transition from, say, a million years in the past to today is actually only getting us, you know, that's only a million years. The entire transition of the Milky Way and Andromeda colliding will take a few billions of years. So this is about 1/2000th or 1/3000th of the history of the galaxy collision in progress. Yeah. So very small amount, right? It's like a fraction of a millimeter compared to a meter stick.
We have time for one more question.
Can I elaborate on the trapezium? Ah, right. Okay, so deep down in Orion, these middlemost stars, these usually are like the sword or the sheath in Orion's belt, or it's the back of the celestial tortoise, depending on how you see it. But down there is Orion's Nebula. The Orion Nebula has, at the heart of it, a star-forming region. new stars being born out of the nebula there. And if you have sharp eyesight, you can see it on a clear night in winter. That's a little bit fuzzy. You can make out the Orion Nebula. The trapezium in the middle has a variety of very massive, very young stars that are formed there, and they are blowing away all the extra nebulosity that they formed out of it. So these hot young stars are pushing away all the other gas, and it's forming a giant cavity there. And as they're blowing it away, you can see other stars that are in the process of forming are creating bow shocks around them. And so if you look at pictures of the Orion Nebula, you'll see little bow shocks in the image of the gas that's being pushed away by the trapezium stars in the center. So there's a lot going on there. And in fact, it looks like there's perhaps been other activity in Orion that I don't have time to go into. But thank you for the great question, and thanks to Hunter and Ray.
All right, Nick is a very special presenter for me. He's been my manager at the Fisk Planetarium, and he's taught me a lot of things, so I really am grateful for Nick. Let's hear it up for him one more time.